We know alkanes are saturated hydrocarbons having the general formula CnH2n. Let's see what are the different ways and methods of forming these alkanes. Let's start with the first alkane, that is methane. Let's see how we can form methane in the laboratory. This is the setup that we use in the labs. In this test tube, we keep a substance known as sodium ethanoate and calcium oxide is added as the catalyst. We then heat it. The gas, that is methane, is evolved. It is collected on the top. Let's see how this happens. As we heat it, the gas methane is evolved. The bubbles are of methane. Since the gas is insoluble in water, so it is collected on the top. So let's see the reaction that is taking place. We have sodium ethanoate. This substance CH3COONA is known as sodium ethanoate. When we react it with sodium hydroxide in the presence of a catalyst CaO at a temperature that is 300 degrees Celsius, it forms Na2CO3. This is how the reaction is taking place. Na2CO3 separates out and it forms the gas CH4. And CH4 is methane. Similarly, if we have to form ethane, which is C2H6, which reagent should we use here? We know we have to form C2H6, so we need C2H5 here. So we use a reagent known as sodium propanoate. This is also known as sodium propionate. These are the two names for this substance. So instead of CH3COONA, we use C2H5COONA. So again, Na2CO3 separates out and we get the gas. When C2H5 reacts with H, we get C2H6. That is, ethane gas is evolved. The upward pointing arrow shows that the gas is released. Another way to prepare the alkanes is by using nascent hydrogen. Nascent hydrogen is a very reactive species. When it is made to react with iodomethane, which is CH3I, we have two atoms of nascent hydrogen. One atom goes and forms HI, and the other atom goes with CH3 to form CH4 gas, which is methane. Similarly, if we take C2H5Br, we make it react with nascent hydrogen. So again we have two atoms of nascent hydrogen. One atom goes with Br to form HBr and the other atom goes with C2H5 to form the gas C2H6. So nascent hydrogen is a very reactive species. This can also be used to form the different alkanes. This is another method known as Wood's reaction. In this, again we take the chloro, iodo or bromomethane. So let's start with iodomethane. We take two molecules of iodomethane, we react it with two atoms of sodium. So now it forms ethane. Since we are starting with two molecules, it forms CH3 plus NaI. Now instead of CH3I, let's take the higher alkane. Let's take the higher iodoalkane, which is iodoethane. So in this case, we have C2H5I. So now this forms C2H5 bonding to C2H5, which is, we know, C4H10. And this is butane. So when we start with CH3I, we get ethane. When we start with C2H5I, we get butane. Now if we take the higher one, say the third one will be C3H7I. This is the next higher alkane. So we have iodopropane. If we take two molecules, we'll get C3H7. So you observe that in this case, the 2 of carbon is doubling to give the alkane having 4 carbon atoms. If we start with an iodoalkane having 3 carbon atoms, the product is the alkane having 6 carbon atoms. So whether we start with an even or an odd numbered iodoalkane, we get an even numbered alkane. So by using Wood's reaction, it is possible to form alkanes containing only even number of carbon atoms. So this method cannot be used to form alkanes containing odd number of carbon atoms. Is it possible to form alkanes with odd number of carbon atoms by using the Wood's method? No, it is not possible, because whichever reagent we start with, we always get the number of carbon atoms double the initial number. So it is never possible to form alkanes containing odd number of carbon atoms using the Wood's method. So it's not possible, so the statement is false.